Guys, in this video we are going to see how to find out the magnetic field caused by this circular current loop using Biot Savart law. Biot Savart law says dB is equal to mu naught I dl cross r over 4 pi r square, and if you want to know how did we derive this equation, you can watch my previous video. I have explained how did we derive this one. Okay, now let's look at this one. Here what we are going to do is we are going to take a small segment of this current wire and we are going to call this one dl, right? And if this is dl and the magnetic field caused by this small segment is going to call dB, right? It has two components. It has x component and y component. And if you look at this one, like if you take the small segment along this way until the half of this circle, you will have the y direction on the upper direction, right? But when you go to the bottom part, you will get the y segment, like this y component of this magnetic field direction is going to be downward. So you can see that magnitude, same magnitude, opposite direction. So the y components are going to cancel each other, but the x components remain the same because for all of them the x component is going to be only in this direction. So we just have to find the x component. That's going to be the total magnetic. If we integrate that one, that's going to give us the total magnetic field. Now to find the x component, and we have to know that in magnetic field everything is going to be perpendicular to each other. So when we have phi right here, that's phi is going to be equivalent to, like, this angle and this angle are going to equal, right? That's the another thing you have to know. And from this one we can say dbx is going to be, this component is going to be cos theta, like db cos theta, db cos theta, cos phi actually, because we are using phi right here. So cos phi. And to find out cos phi, you can look at this one. Like here we have phi, and we know that cos phi is going to be adjacent over hypotenuse. In our case, adjacent is going to be a because the radius of this circle is given by a, right? So from this one, if this is a, this one also going to be a. So we can say cos phi is equal to a over r. So we are going to replace this cos phi with that one, and also we have the dB, that is this one. Now let's go ahead and copy this one down. Mu naught I dl cross r and divided by 4 pi r square, and if I multiply this a over r, this is going to become r cube, and here we are going to have a. Okay, and this is our dbx. Now here we can do one more thing, like we can replace this r cube in terms of a and x, and if you use the Pythagorean theorem, you know that r square is equal to a square plus x square. Therefore r is going to be equal to square root of a square plus x square. We can also write this one as a square plus x square power half, right? So if we replace this r with this one, this is going to become mu naught I dl cross r, and we know that in magnetic field we are going to have everything. This is basically the direction, right? And instead of this one, we can also replace this one with magnitude of dl times sine angle, and the angle is going to be 90 degree because it's perpendicular. So this is going to be just 1. So we can get rid of this part. We can just multiply this one with the a and then divide by 4 pi, and we found out the r value, that's a square plus x square power half. And if you replace this one, instead of r, this is going to become a square plus x square power, here we already have 3, and this half, the bottom part comes here, this is going to be 3 by 2, right? And this is going to be our dbx. And also we can replace this dl, and if we take an angle, for example, let's take this angle right here. If we take this one, and if we call this angle of this dl is d theta, then we can say dl is equivalent to a d theta. Okay, we can replace this dl with a d theta. So that's what I'm going to do right here. Here we are going to have dbx is going to be equivalent to mu naught I, instead of dl I'm going to plug a d theta, so this is going to become a d theta, and we already have an a right here, so this is going to become a square, and then we are going to have d theta. In the bottom we are going to have 4 pi a square plus x square power 3 by 2. Okay, so this is our dbx. Now to find the Bx, that's going to be the total magnitude, right? To find the Bx, what we are going to do is we are going to integrate this one, both sides. And if we integrate this side, here you can see in the other side we have only this theta value is the only one that's changing because we have d theta, so others are going to be constant, the others don't change. So what we can do is we can move the others to the front, and we can write our integral. So this is going to be mu naught I a square divided by 4 phi a square plus x square power 3 by 2, and then we are going to have integral. Since this is a full circle, the limits of integration is going to go from 0 to 2 pi, and then d theta. And if we integrate this one, this is going to give us, okay, let's do the integration. This is going to give us mu naught I a square divided by 4 phi a square plus x square power 3 by 2, and then here we're going to have theta going from 0 to 2 pi. Okay, this is only for this part. And if we plug 2 phi, we are going to have multiplication of 2 pi, but this 0 doesn't do anything because this is going to completely make this one 0, so we don't have to subtract 0 from this one. We can just show the multiplication of 2 phi. Okay, so this is going to become mu naught I a square times 2 phi. Let's get rid of this one because this might confuse things. Okay, mu naught a square times 2 phi over 4 phi times a square plus x square power 3 by 2, and here we can cancel this 2 phi and 4 phi, so that's going to give us 2. And finally we end up with Bx is equal to mu naught I a square over 2 times a square plus x square power 3 by 2, and that's going to be the magnetic field caused by this current loop, circular current loop. And if in case if they ask for the magnetic field at the center, you can make this x is equal to 0 because x is the distance from the center, and if it's at center we are going to have x is equal to 0. In that case we are going to have, okay, let's say x is equal to 0. When x is equal to 0, we are going to have Bx mu naught I a square divided by, this is going to become 2 a square power 3 by 2, so square and this half cancels, right? Power half cancels, so we are going to have a cube right here, and finally we will end up with mu naught I over 2a, and that's going to be the expression when we have the, like if we try to find the magnetic field at the center of this loop. I hope this helps. Thanks for watching.